as we think about farming, we like to use the term biological farming. And because we really believe, and you'll hear, of course we'll talk about this all day really, that the whole foundation of everything that happens out there in that field, from what happens in the soil to the final plant and the grain or fruit that comes off of that, is all goes back to, and the whole key is biology, life out there. But it's all part of a whole picture, a bigger picture. When we think about biological farming, there's a number of benefits, and we'll keep coming back to these kind of throughout the day. Tilth of our soil, we'll look at that and how that's defined. Organic matter, how do we build our soils versus the concept of wearing them out. Darkening soils, can you actually change the look of that soil? That weatherproofing, how do we get through those stressful years better? Reducing nitrogen and phosphorus needs. How do we grow a very productive, very healthy crop without buying as much NP and K in inputs? Shelf life, the quality of what we produce. Can we improve that? And then finally, what we all think is the bottom line, at least, increased yields. If we can get those last two together, shelf life, quality, and yield, then we've really got it to where we want to be. We always want to think big, because we're farmers, right? We want the biggest yield. We want the biggest crop that we can get. We all wish every year corn had that many kernels on it, right? So let's try to think big today. What can we do? How can we make things bigger and better? One approach is how can we grow good high yields and lower our costs? Ultimately, farming is about profit. It's about the bottom line. Not necessarily the highest yield, but how can we make the most profit per acre? So one approach to that is how do we lower costs and still get good high yields? Another concept is, well, how can we get better yields? How can we get higher yields? So we'll just keep these things in mind as we go along. So we've got to think about what is really possible, not just what we're all used to, maybe. So how can we grow, whether it's 300 bushel corn or more tons of dry beans or more potatoes, whatever it is, how can we do that biologically? How can we do that using the life that's out there in the soil? Well, we believe you really have to kind of earn the right to be able to do that. It's not just about throwing a magic product of an organism out there, and then all of a sudden you're biological and everything happens. We've got to start with the soil. Where are we at with our soil? So we've got to start with the basics then of the soil that's out there. So there's three kind of main components, things that are going on out there. The physical component of that soil. So that involves, we're going to talk about tilth, and so that impacts our seed bed, our root system, how water and air flows down through the soil, and the home for these microbes that are out there. Then there's the chemical part, which that's helping supply nutrient needs of the crop. When we think about NP and K and trace minerals and all those kinds of things. And then the biological part, which Ariel is going to talk more about here in a couple minutes. How do we really both expand the scope of that biological community out there, both in quantity, but then also diversity, the different kinds of organisms that are out there. And then really this all comes back together because your biological changes physical and chemical characteristics of the soil. So we'll keep talking about that, how all three of these impact each other. And that's where we go back to that statement, well, you have to earn the right to grow biologically. Because you got to get all three of these things, working together, and they all impact each other. Healthy soil, it's kind of in the textbook. It's defined as soil is 50% pore space, half of which is air and half of that's water. It's 45% minerals and then 5% organic matter, or 4, or depending on what kind of soil you have, somewhere in there. But those rough ranges. So if we have 20% organic matter and our pore space is, maybe it's way too much or way too little, or say we have a heavy clay soil that's super tight, and all of a sudden we have zero pore space, Then those things get out of balance. We don't really have that healthy soil condition where, again, is it going to be home for the microbes, and is it going to make nutrients available, and are all those things going to work right? You got to have kind of the right balance, or proportion. One way to think about that or define that is the word tilth. Now, to me, tilth was always kind of a hard thing to explain. It's not maybe just a dictionary term for it. It's more a feel and a look. And does that soil have kind of coffee ground structure? Does it have an earthy smell to it? What does it feel and look like out there? That's kind of hard to explain. But we know that tilth, impacts virtually everything that we do out there. Whether it's air and water movement in the soil, the microbes, how nutrients are made available or tied up, all the way down to weed control, which we're going to hear some guys share about this afternoon. And really it's all related to that tilth, that structure. What kind of soil are we working with there? One of the biggest things that hurts tilth is compaction. And that relates to virtually everything that we do out there. Every trip that we make or don't make, what day we did it, what time of the day we did it even, all different kinds of things. So we always have to keep that in mind. When I'm making a trip out there, what is that doing actually to my soil? And is today the right day to be out doing it, or should I actually stay at the coffee shop for another day or something? Two parts to tilth, kind of, is flocculation and aggregation, when we start thinking about these particles of soil that are out there. And not to get, super technical or scientific about it, but the flocculation part is really a chemical process, and then the aggregation is biological. We'll try to make some sense out of that. So then we think, well, what came first, the chicken or the egg? Did you got to have a good tilth and structure first, and then you'll have a good home for the biology, or you have the biology first and it creates the tilth, or what came first, what came second? And we can, of course, impact either of these at any one time, either by working with our biology to create better tilth, or doing things like with our choice of tillage. So it all still has to work together. It's a combination. You got to work at all these processes at the same time to kind of move along that direction. So the flocculation, that's a condition which clays, small particles become attached and form a fragile structure called a flock. That's what they call it. So another way to think about it is a clump. And I think we got a little picture here in just a minute. Dispersion, well, that's when they're pushed apart. They're forced apart, right? So you have all these separate little pieces floating out there. So the soil is separated into single particles in that. So there's a picture of like dispersion, all these single particles. And there's a picture of flocculation, where they're all kind of stuck together or grouped together, right? Okay, so when they're clumped together, so we read at the top, see they can be unattached, dispersed, or clumped together in aggregates. So that starts to become what we think of as an aggregate, a bunch of little particles, grouped together in a clump, kind of, or a flock. An aggregate, then it's defined as where we get a lot of, the arrangement of primary soil particles, the sand, silt, and the clay, around organic matter, and through particle associations. Now, what does that mean? That means there's chemical compounds out there that are helping to glue things together. So gluing these several little particles together into one bigger, aggregate. And part of that comes from the biology, helping giving off exudates. And the plant's giving off exudates, the biology, the microbes, are also giving off compounds. They're helping to stick, the particles together. So they help build those aggregates out there. So then we say aggregate stability is a good indicator of soil health. Let's see. Soil aggregates. Yeah, here we're saying that these organic compounds, are helped formed by bacterial fungi and hyphae. So then we get these groups of soil particles that are bound together, much more strongly than they are to the particles next to them. So when we talk about tilth, and we think one of the terms always used is a coffee ground structure. So it's like more coarse particles. It's not just all like a finely ground material, So these coarse particles, this coffee grounds, that's where there's a bunch of little particles stuck together into one bigger one. And then in between these coarse particles, then you've got room for the air and the water and the soil to breathe, and microbes to live, and nutrients to become available, and all these things. So the term here is clumping the clumps, You start grouping those together. This is just another little diagram of that. If something's dispersed, they're kind of scattered all different ways. If they're flocculated, there's plates out there like perpendicular to each other, or they could be at angles or something like that. If they're aggregated, well then they're plates that are like stacked together into small groups. But then the ideal is both flocculated and aggregated. So there's some stacked together, but then there's also some perpendicular. And then when you have this arrangement, you have the maximum room for air and water and everything to flow down through there. Another analogy of that is a stack of lumber, and here we have various shapes and sizes of 1-bys, and they're stacked, separated apart, so there's little room in between, and they're crosswise, but there's a lot of room for them to breathe that way, right? Air can go through there, and moisture can drain, and they're going to cure better, and those things. Compare that to the pallet of plywood, and what goes through that. Or if you have water between two pieces of plywood, does it ever go anywhere? Does it ever dry out? No, there's no air there, there's no room there. So the more desirable situation is that where it can breathe and air and water can go through, and there's room in between the different particles, the different aggregates for microbes to live and nutrients to become available and all these different things. So just one way to think about that. So when we do have this kind of scenario out in the soil, that's just a wonderful place for the microbes to live out there. That's one of the things we're trying to create in our soil, is that good habitat, good home for the microbes. And one of the tools we commonly use to help create this is, if we have a tight soil, we have a clay soil, things are compacted. So what can I add? What can I do? How can I change this thing? We think of, well, what can I add that's going to help loosen this thing, flocculate it? We often then come down to hearing about calcium, because calcium here has a flocculating power of 43 compared to, say, potassium at 1.7 or sodium at 1. So when we're talking about lime and gypsum and liquid calciums, all these things, that's one of their primary roles of calcium out there, is to help flocculate and loosen the soil. So just something to think about as we think about how do we build that better soil. And just a couple of the calcium sources, as we mentioned, with the lime. We work with several liquid versions of that. And a couple of these on the conventional side, we're putting calcium with humic acids, because humic acid has natural flocculating powers, ways to loosen up compacted particles. Caliber is kind of an organic approach to that as well. So, and of course our ideal, our goal is to get soil that looks really nice. Again, how do we define tilth, It's not just a word, it's a feel and a look. And you go out there and you can put your hand into the soil and you can smell it, and it has an earthy smell, and you can take up a ball and crumble it, and it still has a nice particle kind of consistency to it.